we created our first package. So what I'm going to do right now is I'm going to just jump into the terminal, because the other day we were reviewing a Conan package recipe. Package recipe is a Python script we use to create packages. And I told you the past webinar, don't worry too much about this recipe, because there are utilities that can generate it from a template. So to get started, today I'm going to create a package recipe. Is going to call hello, and I'm going to add the -t. I will explain it right now. So this helper command will create a package recipe for me. If I check the recipe, okay, I will see that it's exactly the same that we were seeing the other day. There are the methods we explain, like the source method that is doing a git clone to get the sources. In this case, we are packaging a library which sources are living in GitHub. Then we also have the build method that is calling CMake to build the binaries from the source code. We have the package method that is copying the artifacts, the headers, and the binaries, and putting them in the package. And then finally, we have the package info method that is providing the consumers the information they need to link with this package. So this would be the package recipe. And the other day, we were using it. So we created the recipe. And then we were asking ourselves, how do we know that this recipe is working? It is working, it is failing, it is packaging properly, probably the URL for git cloning is wrong. So to really know that this recipe is working, we created a test project. And from this test project, we used the package recipe, and then we created the binaries. We built the binaries from sources. And as everybody worked, we concluded, okay, so this recipe is good and it is working. So when I typed the Conan new command, I added the -t is for test. It will create a test package folder for me. You can see the folder here. Okay, and this folder is just a project. It's just a project exactly the same as the projects we saw the other day. So it will have a very simple example, CPP, sorry, beam test package example CPP. It will have a very simple application, an executable, that will use the package we are creating. The CMake list, it will be also the same as we were seeing the other day. And then inside the test package, we have another Conan file.py. Let's have a look to this. Okay, so here we have a Conan file.py that it is not a package recipe, okay? Because it doesn't have a name, it doesn't have a version, and if you read it, it doesn't have a package method either, okay? So it is just a recipe for consuming, exactly the same as we were, the Conan file.txt that we were seeing, the first example we executed the other day, is exactly the same. So what we have here is a consuming recipe that will define that a requires section, and the requires will depend on the package that we are creating. Okay. Then we will have the build that will call CMake for us, and finally we will have a test method here that will execute the example application. So what is this recipe is doing here? It is just consuming the package that I'm creating, is building an example application, and then it is running the example application. Okay, but it is not creating the package. So the Conan file that is actually creating the package is the Conan file.py that is in the root folder. Okay, so with this test package consumer project, I can automate the whole process of creating and testing the package very easily, because all I have to do is to run Conan test package. And this will do two things. It will first put the recipe into the local cache with the Conan export method, then it will build the binary for me. So right now it is building the package, the hello package. Okay, it is calling CMake. It is building with Visual Studio, that is my default. Okay, and finally it's creating the package. And now we see that it is moving to the project. Now it is building the test project, the test package project that is local in my folder. Okay, this project is linking with the package, and finally it is executing the application, and it is printing the hello world. So this is the way to create a package and to know that it is working, because my test package application has been able to link and to execute against the library that is inside the package. Actually, now I can search my local cache. And my local cache, I will see that I have this recipe here, and I can also search for details for this recipe, and I will see that I have a package for it. I have a binary with this identifier here, okay, and I can see the specifics of this binary. For example, it is a 64 bits binary built for the release build type with Visual Studio version 14. Okay, so one of the major strengths of Conan is that it can easily handle many binaries for the same recipe, for the same library. So in this case, as I already have all the test package functionality, it's very easy to create any number of binaries for different types. For example, I can just run a Conan test package, and now I'm going to specify a different setting. The setting, there are several of them, like compiler, operating system. I'm going to specify that I want to build, for any reason, I want to build a binary, a package, for 32 bits. So I specify the architecture being x86, that is equivalent to the 32 bits Windows architecture. And now it is building again the package, because the other time I ran the package, it created the 64 bits, and now it has to rebuild, obviously, for the 32 bits. And now it is again building the consumer application and running the consumer application, hello world. So the 32 bits package is working too. Now we can inspect. If I do the Conan search for the package that I'm creating, now I can see that I have two different package binaries with two different identifiers. Okay, and if I go to the settings, I will check that the first one will be a 32 bits architecture package, and the other one will be a 64 architecture package. So this process can just be repeated for any number of configurations I want to do. If I want to for example, to build a debug package, I can do it. If I want to change the compiler version and build with an older version of Visual Studio, I can just repeat Conan test package, specifying the settings, and it will build every time one different binary for me. So now that I have these two binaries, I can upload them to my, so I'm going to specify that I want to upload them to my remote. My remote is going to be Artifactory in this case, that I already saw the other day how to configure it and how to set it up. Is called art, and I'm specifying that I want to upload not only the recipe, but also all the binaries that I have built for this package. So I'm going to specify this, uploading, and let's check into Artifactory. Let's refresh, and I can see that in my repo, I have this package with the hello 01, and then I have two different packages. And in each one, I can also inspect the properties. If you want also, you can search by properties. For example, if there are 32 bits architecture, you can search for them. So here you can see that I have two different, one is 64 bits and the other one is 32 bits. And from there, now these packages are in Artifactory, they can be shared with my team, and everybody can use them exactly the same as we were seeing the other day. So now I'm going to briefly review some concepts that I think that are better explained with a couple of slides. The first one would be this one. Okay, so we have here like the two parts. We have the server side and the client side. The client side, both of them, the layout is basically the same. We have any number of packages. Each package is identified with the package name. Typically will match the library name. In this case, package. We will have the package version, and we will have the user and the channel. Okay. If we change any of those four things, we will have a different package. So if we have the channel, it will be a different component. We can interchange them, but it will be a different package. Okay. And for each package, we have two different things. First, we have the recipe. The recipe is basically the Conan file.py that contains the Python scripts that define how to build the packages. And then we have any number of binaries, any number of package binaries. In this case, we have created just two of them, one for 32-bit architecture and one for 64-bit architecture. But we can have any of them. Actually, we can have any number of them, and all of them will be connected to the recipe, even if they come from different operating systems. So if now I go to Linux and I build a different binary and I upload it to my server, it will keep connected to the recipe. So I can store all the binaries for different operating systems. I can store them in the same place and refer to the same recipe. Okay. So this when I uploaded the package, basically it just uploaded both the recipe and every binary. So it is more or less the local cache is just a reflect or just a cache of the structure of the server. So now that I have my packages in the server, I have my package binaries in the server, I would like also to review what we were doing the other day, just to understand what is happening. So let's imagine that now we have a server, we have the binaries and the package recipe, everything we have in Artifactory. And now we have a developer that has just installed Conan. So their local cache is empty. This is the lower part of the slide. Okay, he is starting a new project. So they have just written a Conan file.txt with some requirements, generators, options, whatever. Okay, and now he wants to install the binaries. Okay, so he will issue a command like this. He will issue like a Conan install, and he will specify his settings, their settings, or maybe they will use the defaults, but they will have some specific settings for their machine. Let them, for example, in this case, let it be the compiler GCC with some version, with some architecture, whatever. So what is the process of installing the binaries from the server to the local cache? Okay, so the first step would be, okay, so I'm requiring package version 1. So I'm going to check if this recipe exists in my local cache. So as I have just installed Conan, the local cache will be empty. So the next step will, okay, let's check the remote. Let's check if the package version 1 is in this remote. Okay, it is there. So it will fetch the recipe, and it will bring the recipe to the local cache. Then this recipe is a Python script, and it will get the settings and the options from the user side, from the compiler GCC, the version of the setup of the user, and it will evaluate. It will evaluate against the recipe, and it will say, okay, so for these settings and this recipe, I need this binary, this specific binary, okay, with this identifier. The identifier is basically the hash of the settings and the options of the package. So I need this binary. Now there are two options. The first one will be, okay, so this identifier, this binary, already exists in my remote. If the binary exists in the remote, then the default is to use the binary, and it will fetch the binary from the remote. But if this binary doesn't exist because it has not been precompiled, for example, or just because the user, they want to build it from sources. They want to make sure to build the package from sources because they don't want to reuse the binary that is already stored in the server for any reasons. So the other option would be, okay, so let's build the binary from sources locally in the local cache. And once the binary of the package is in the local cache, then the last step will be, okay, so now I have the packages, I have the binaries. The binaries will have the include directories with the headers, the libraries, everything, and it will generate a file. In case that we are using CMake generator, it will generate a Conan build info.cmake file with all the information, with all the variables that in CMake syntax that the user requires to link against this package, because this package will typically live in the local cache. So the path to the binaries here will be variables in the .cmake file, and this is the way that the consumer can easily consume packages and know the package libraries and everything. So let's advance a little bit more into some different things. Okay, so in this example, we are doing this. We are executing git clone, and we are bringing the sources from GitHub. What happens if I don't want to do that? So I'm going to show you a different approach. It will be, yeah. So now I'm going to create a package recipe. I'm going to specify the -s from sources. So now what I'm going to have here is a different approach. Instead of fetching the source code from GitHub, I'm going to embed the source code into the recipe itself. So now the source code, it is in a hello folder that this template has generated for me as an example. So I have the files locally. This would be the approach I would use if I want to put the recipe into my source repo. So if I have a repository in GitHub and I want to put the Conan file into the repo itself and not in a different repository, then I probably use this approach, okay? Because in this approach, we will see the recipe, the package recipe. Okay, so now there is no source function. So the source method doesn't exist anymore. Okay, because now I don't want to execute anything. I don't need a git clone. But instead, what I have right now is this. I'm specifying export sources, and I'm specifying to copy everything inside the hello subfolder. So this is what it's doing. This line here, it is copying all the source, all the files that are inside the local hello folder, and putting them into the recipe itself. So this would be the concept of a snapshot. It is actually a snapshotting the source code and put it into the recipe. So now this recipe is self-contained. It doesn't require source code from elsewhere because the source code is in it, okay? Actually, the implementation is quite efficient, so if you don't need to build a package from sources, it will not retrieve the sources. But that's a different story. The concept is that the source code is not outside of the recipe, but it is inside the recipe itself. Besides that, the functioning of the recipe is basically the same. I can just create. I will do just the Conan test package. Now you will not see any git cloning. Typically a trace that will appear here because now it is not required. But besides that, the process is exactly the same. It is creating a package, it is building the package. Now it is building the consumer application to test that the package is properly working. And finally, we have the hello world. So it seems that the package is also working. I would like to explain one thing that is let me see. That is the options. Okay, so so far we have been able to build two different binaries, and what we were doing, we were changing the settings, and we were changing specifically the architecture setting. and we were specifying 32 bits, 64 bits. Okay, the settings are something that will affect the binary. If we change any of these settings, the binary will be a different one. Okay, so if, of course, if I change the build type from debug to release, the binary will be different. So the settings are something that are typically project-wide, and they are something that are defined by the end user. So it is not something that can be defaulted. You cannot say that my default operating system is Windows, because if you are running in Linux, that doesn't make sense at all. So settings is something that is defined by the user machine and cannot be defaulted. But packages can also specify a different configuration that would be the options. In this case, a very, very typical one, I would say the most typical option in C++ packages, would be the, okay, I want to build static or shared libraries. Okay, so I can define any option here with any, this is just a string, but shared will be a typical convention, of course. And here you specify the possible values that this option can have. Okay, and then you can specify default options. In this case, it makes sense. You can say, okay, this package, this hello package by default will be a static library. And if you want a different behavior, you can specify it. And you want to say that it will be a shared library. But by default, it will work. It will work in all operating systems. It will work with all compilers. Static library will work. So it can be defaulted. Okay. How can I specify that I actually want to build a shared library? I will do it right now in the command line. What I wanted to explain first is, okay, I have this option, and what I have to do is I have to translate this option to my build system. In this case, it is very simple because CMake, it has an option. It has a variable, it's called build shared libs. If you put it on, it will build shared libraries. If you put it off, or if you don't define it, it will be static libraries. So what I'm doing in this line, I'm translating the value of options shared to the CMake syntax. Okay. If you have a different build system, you can do it exactly the same. For example, if you are using make files, probably you will build a different target, and you will call here that you are going to build a different target. But in any case, it's the responsibility of the package creator to translate the options to the proper build commands. In this case, very simple. But if it is a different build system, you can do it your own. So how can I specify now that I want to build a package with a different option? Instead of specifying a setting, I will specify an option with a -o. It will be an option for the hello package, because options are per package. Settings are typically project-wide. Even you can specify settings for a specific package, but typically they will be open project-wide. Options are basically package, just specific per package. So I will specify that for the hello package, I want to build and test a shared library. So I specify hello colon shared equal true. And now it is creating the package. Here you can see that is copying some DLLs that are the shared libraries. And it is working. So I can just do the search hello and now I have three packages. I have the packages that I build that are shared equal false, and then I have a dynamic, I have a shared library here too. Okay, so I can repeat this, and I can build a lot of shared libraries with different settings, exactly the same. So here we have a small trick, because okay, you are generating DLLs. And DLLs in Windows and in other operating systems, they have a problem, is that they have to be in the path. So what happened, how did you manage to actually execute the test and make it work? Okay, so there is a small trick here I'm going to inspect the test package Conan file recipe, and I will show you about this line, the imports method. The imports method, what it is doing, it is copying, it is extracting files from the local cache and copying them to user space. In this case, this imports method is saying, okay, if there are some DLLs files into the packages you are dependent on, copy them into my local user bin folder. Okay, so in this case, it is copying the DLLs just besides the binary that I'm going to execute. So in this way, it is not necessary to mess with the system path. It is not necessary to put the DLLs in the system32 or any other folder, or to modify the system path environment variable, because you are copying the binaries. It's convenient for testing, or it is convenient for just extracting the binaries because you want to, for example, to distribute to your final customer. So this will be the imports. Probably it is better explained if we review the packaging process. Sorry, this, not this, but this. Okay. So here we have the lower part of the slide is the user space, the user folders. Okay. So first, the Conan file is in the user folder. And the moment you execute a Conan export or a Conan test package, the first step is to copy this Conan file into the export folder. Okay, every single square in the upper part of the slide is a folder. It's a different folder. Okay, so it will copy the Conan file into the export folder. And if we specify like the export sources, it will also copy other files like the sources into the export folder. Then there are two possibilities here. If the precompiled binaries are in a remote, then all the mid part of here, the source and build, are not necessary, and we will get just the package, the final packages from the remote. But in this case, we are explaining how it is built from sources. Like when we are executing Conan test package, it is locally building from sources. So the process is, okay, the first step will take the export folder and copy everything to a source folder. For the package reference we are using is package 01 user channel. It will copy everything into a source folder. Then, if a source method exists in the recipe, it will execute it. So here, for example, if we have a source method with a git clone, the result is that the git clone is executing the source folder, and the sources are retrieved from GitHub and copied into the source folder. Then we have to build, and we have to build from sources. We will create a different folder for every different configuration. So if you are building a different configuration with different settings or options, we will create a different build folder because we want a clean build for every different configuration. It will copy all the sources just in case, because there are some builds that will, for example, generate code, and the code generated will be different depending on the build type. So it will copy all the sources in a build, and then the identifier of the package. Inside the build folder, it will call the build function, the build method. It will call cmake or makefile or whatever, and build the binaries. And finally, the package method will extract the binaries from the build folder into the package folder. The package folder is the one that is uploaded to the remote. It's the final result of the package, the binaries that we are really interested in. And the last step, once we have the package folder, then there are two things that we can get out of the local cache. One would be the generated files. For example, the Conan build info cmake is a generated file that will have all the paths to the package folders and the library names and so on. And then the other mechanism is the imports mechanism. The imports mechanism can just copy files like the DLLs from the package folders that are in the local cache, and will copy them and put the DLLs into the user space, into the user folder, so they can easily be repacked or whatever. So this would be the process. So all these squares in this graphic are just folders. So if you go to your .conan folder into your user home, you will see there the local cache. It is very simple to inspect. So I really recommend to go there and to inspect the folders, because it is really easy to understand what is happening. So you have a couple of configuration files, and then you have the data. The data is the actual storage for packages. And for each package, you will have the package name, version, user, and channel for every package. And then inside that, you will have the export, the source, the build, and the package folders. And in each one, you will see the Conan files, you will see the temporary build objects, and you will see the final package. Inside the final package will typically be like the include directory with headers, lib directory with the libraries, and so on. So it's very, if something fails, for example, in your build, you can just go to the local cache and go to the build folder and see what is happening there. Okay, so one of the things that I wanted to explain today also is what happens when we have a different build system. Okay, in this case, I want to build the same, the Hello application, but I'm going to show you inside the Hello folder. I don't have a CPP application anymore. I have a C application. I have a C library. It is the Hello C library, and I don't have a CMake anymore. This project here, it has a make file. So here I can see my old printf in C syntax, and I can see a very simple make file. Okay, so this is the library that I want to package. So let's see how can I build a package for this library. So the idea would be basically the same as we did before. The package method is exactly the same. The package info method is exactly the same. And we only have to change the build method. The build method, now it is not using CMake. So I'm not using the CMake helper. But we have other helpers. For example, we have the auto tools build environment. It will create and manage all the environment variables for a typical configure and make auto tools flow. So with this auto tools environment, I can just change directory with this helper. It's a context that just help me to change to the Hello directory in a clean way, and then I will apply all the environment variables from the helper to the environment. And all I have to do is run make. And this is the helper that allows me to package libraries that are using auto tools instead of CMake. So, but this recipe still is not complete. I will show you a couple of things. So, okay, let's try to build it. So now I'm going to specify the test package. My compiler, I'm using MinGW for Windows, is GCC, and my version will be 4.9. Okay. And now it is complaining. Why? What is this error meaning? You say, okay, settings compiler libcxx is not defined. Okay, because as my defaults are for Visual Studio, you know that GCC, they have to define if they are using the libstd C++ or libstd C++11. So I could do this compiler libcxx equal a libstd C++. Okay, I could do this and it will work. But probably some of you would complain and would say, hey, Diego, you are building a C project. You don't need the C++ standard library at all. And that is true. That is totally true. So the first thing is, okay, how can I do this? So I'm going to specify in a configure method I'm going to do this. Remove self settings compiler. Okay. So this will be it. Okay. This is not a C++. I don't need the lib C++ library setting at all. So I can just remove it from my recipe. So I remove from my recipe. Let's save the recipe. And let's try again. Okay, so perfect. Now I'm building with min.gw a pure C library, and it's working. Okay, so this will be the first thing. You can configure the settings as you want. If you are not interested in a setting, you can remove it. If you want to add a different setting, you can add new settings to your packages. You can define any configuration you want. And then the other thing I want to explain now is, okay, I'm building a C project, okay, with GCC 4.9, and I know that this library will be compatible with all the GCC versions. So if for example, if I try to do a Conan install, and I specify compiler GCC and compiler version 5.1, it will complain. It say, hey, I don't have a pre-built package for this configuration. You have to build it from sources if you want it. Okay, but I say, hey, but I don't want to build a new package binary. I know that my binary built with 4.9 is compatible with all GCC versions. That's not true, but let's assume for this example that it is true. So how can I do this? Okay, so the thing is that you can configure any ABI binary compatibility. You can configure it yourself, up to your knowledge of your package binary compatibility. In this case, if I want to redefine my package binary compatibility, I will just override my package ID method. And all I have to do is specify that my settings compiler version will be any. Okay, so now with this line, I'm saying, okay, so the package identifier will be exactly the same always, irrespective of the compiler version. So now I can build the package. Everything is working. I can search for my package. And here you will see that the compiler version for GCC is any. So right now, and also the package identifier starts with CFF, okay? So now if I install for 5.1, for GCC 5.1, okay, you say, okay, so the package is already installed because the package identifier is going to be exactly the same. It doesn't matter if I specify 5.1, 5.2, 6.1. So all of them, they will use the same package binary that was created with GCC 4.9. And this is more or less the way, just the basics, the way you control the binary compatibility and how you can define the number of binaries, how many binaries you will have for different architectures and everything. And you have full control over that. And to finish today's webinar, I want to do something a bit more risky. So let's try if this works. So I'm going to try to build a cross application to a Raspberry Pi. So here I have a package recipe. You can check that is basically the same, exactly the same as we did before. The same methods, the same source code. It is packaging the same library, the same Hello library. The only thing that I had to do, and it's because I want to do something special. For example, I want to debug in the Raspberry Pi this package. So as I want to debug in the Raspberry Pi this package, and this package is going to be created in Windows, okay, I have to do two things. The first thing would be to specify to GCC some mapping. I have to map the debug prefix to the, so that I let the debugger, I let GDB to find the sources. And then also now I am packaging the sources into the final package. Because if I want to debug in the Raspberry Pi, I need the sources. I need the sources of the library. So all I had to do is to package the sources, the CPP sources, into a new source folder into the final package. But besides these two lines, the package is exactly the same. So how I would build this? Okay, so I could just try to do a Conan test package for Conan test package. And now I will have to specify that my compiler is GCC, that my architecture is ARM. Also, my cross compiler, I would have to specify them like environment variable. CXS will be like ARM, GCC, ABI. In fact, I don't know it. I don't know it at all. And this is a bit inconvenient. So what I'm going to show you is a better way to do it. If you are going to manage different configurations, Conan has something very useful that are the profiles. So Conan profile list. And here I have two predefined profiles that I created myself. Conan profile show RPI GCC 46. So this will show just some predefined settings and environment variables. In this case, I'm going to compile for Linux because Raspberry Pi is running a Linux. I am building for GCC. This architecture is the ARM v6 architecture. The debug build type, the compiler will be GCC 46. And then I'm also defining the cross compilers. These are the cross compilers I install. I'm in Windows, so I downloaded them and put them somewhere in my computer. So I'm specifying the package, all the settings and environment variables and everything that it needs. So then it is very convenient. These are just text files. You can just write them in your computer. So you can have any number of profiles. Each one will live in a different file, and you can even put the profiles in your source repository and use them from there. You can share their profiles with your team. They are just text files, so it's very simple to manage them. So I can create this test package, and now I'm going to specify that I want to use this profile. Okay, so I have a message cross-platform from Windows to Linux. Here you can see that it is using this Raspberry Pi cross-compiler. And now it is building the test application. Of course, it is not running the test application, okay, because I'm in Windows and it is cross-building. So what I did in my test package, consumer application, I did this check. If my platform is different from the operating systems I'm building for, I just check that the binary exists because I cannot run it. But if the platform matches the operating system, then I'm in native and I can just execute the example. In this case, I didn't execute because I'm compiling for Linux in Windows. It doesn't match, so it just checked that the binary exists. Okay, so I created the binary, and what I'm going to do is, of course, I'm going to upload to Artifactory and all the binaries. Okay, everything is good. And now let's try. Now I'm going to log in remotely into my Raspberry Pi. Okay, looks good. As I told you, Conan runs in many different platforms. It is portable Python. So I'm going to move to this consumer project. This consumer project is just an example project. It's very simple, nothing special. Just it will just requires the package that I just created. So let's make sure that everything is clean. You can check Conan search in my Raspberry Pi. It will show an empty local cache. There are no packages there. So what I'm going to do is I'm going to install the package from Artifactory that I created from Windows. So Conan install, and I'm going to use the debug type. Okay, so it got the binaries from Artifactory, and now I can create my project with just pure CMake. As you can see, the Raspberry Pi is quite slow, so it's very good that I actually created my package cross-compiling from a most powerful machine. Yep. And let's try to build it. Okay, so I built my application. Here, I linked with the package that was cross-compiled in Windows for the Raspberry Pi. And also, now I can check that I can debug this application. Let's start. Okay, breakpoints, and I can step. And you can check that now I am actually into the source code of the package that has been retrieved from the package and put there. So my debugger in the Raspberry Pi can actually debug the application. So let's finish. And with this, I would like to conclude my presentation, just remembering that we will be in Napa in May, in SwampUp, talking about all these things. There will be training about Conan. So if you can, it will be an amazing opportunity to join us and learn more about Conan. And that today it was the part 2 of this 3 parts webinar. And soon we will be doing the last one. It will be more centered about DevOps and different packaging approaches, continuous integration, deployment and distribution. So keep tuned to the JFrog webinar pages, because we will be announcing next one soon. Okay, so thanks very much. So now, if there are any questions, I would love to.
If anyone has questions, please type them in the Q&A box at the bottom of your Zoom screen, and we'll be happy to answer them.
Okay, so there is a question from Sebastian. Can you build a package from source without making a copy of the source to the build directories? Maybe linking. And the answer is no. it is not possible. So the source code will be actually here. The source code will always be copied for every build folder. So as most things, this is a trade-off. In this case, we prefer to absolutely make sure that we have a clean environment every time we build, because there are some places that the source code is actually changed. When you run, for example, configure, it will generate headers. For example, the typical config.h header, and it can create the header into the source tree if you're not careful. Or you can be running some code generation approach. For example, you can be running Google protobuf that will generate source code from the proto declarations. So we wanted to make sure that we really have a clean environment. So we are always copying the source code to every build folder. And the approach works perfectly. The only thing that if there was something to take away is that it takes a little bit more of this space. But this space is very cheap. The time for copying it is just a fraction. It's not 1% of the time that you actually need to build the package. So it is nothing. The disk space is very cheap. And also, if you want, after building, you can specifically remove just the build folder. And you can keep the export, the package, you can keep everything, and just remove the build folder, the temporary folder, if you want to free this space. So this is the reason we prefer to make sure that the build is always clean, and we don't allow to share the same source code for different builds.
Thanks, Diego. Any more questions?
Any other question?
So we have another question from Sebastian. The question is there an option to prune old binary packages? Diego.
Yeah. Actually, there is none, but I strongly suggest to submit a GitHub issue because I think this is an useful feature. What we have right now is if you run the Conan search, as I did, you will find that there are like outdated, there is a field that is called outdated. It marks when the package binary was generated from an older package recipe. And probably you could use that field to automatically remove old binaries if you want. But this is not implemented. But I think that being able to clean like old binaries, it will be an useful feature. So if you want to submit it to GitHub as a feature request, I think it has chances to be implemented.
And again from Sebastian, how can I have additional settings that affect the binary, like linked against glibc2.xy via package ID?
Okay, yeah, that's also a very good question. So I'm going to show you. So this will be my local cache. In the local cache, there are several files. One of them is called settings YAML. Okay, so this settings YAML has the predefinition of the settings that are allowed. So you can just change. These are the predefined settings, but you can change them. For example, if you want to add a new operating system, you will go here and you will add your operating system. And if you want, for example, in this case, you want to add, you have like compatibility, you want to add compatibility for glibc, you can specify a new one, glibc, and specify here like your own values. For example, GCC or 2.7, 2.8, whatever. And you can add your own settings there if you want. Okay, so as long as then you can share this with this file with your team, and as long as you are using the same settings YAML, everything will work. So actually, this is very common. Well, we have active users now in Conan. Some of them, they will redefine the settings file to account for their own settings. A typical one would be the Red Hat, because Red Hat 6 and Red Hat 7, they will have some binary compatibility issues, and you could just add the glibc setting, or you could add like a distro setting, and you could distro setting, and the distro being Red Hat 6 and Red Hat 7, and this will allow you to specify different binary compatibility, taking into account that you can have Red Hat 6 and Red Hat 7 with the same compiler, but the binaries will be incompatible because of the glibc underlying library.
Okay, that's all the time we have for now. Thanks everybody for joining us today, and thank you, Diego, for your time. We'll be happy to send you an email with a recording of this webinar and any relevant links in the next couple of days. Feel free to contact us with any other questions that you may have, and we'll be happy to answer them. Thanks very much, and
Thanks
goodbye.
very much. Bye-bye.